How my microservices communicate. First, I will explain how the communication model in my system works. My application uses four different communication methods, which together make the system fast, scalable, and reliable. The first one is REST API communication, service to service. The second one is API gateway communication, front end to back end. The third one is WebSocket real time text editing, and the service sent events, live document updates. The first one is REST API communication service to service. Inside the backend, the primary communication method is REST APIs. The user service, the document service, and the version service each handle their own responsibilities. But whenever they need information from another service, they communicate through HTTP REST calls. This communication is synchronous, meaning the service wait for a response before moving forward. All communication happens using lightweight JSON data. For example, when a user edits a document, the document service detects an update. It sends a REST call to version service saying, please store a new version of this document. This way, service stay independent and maintain clear boundaries. The second one is API gateway communication, front end to back end. The front end does not communicate with microservices directly. Everything goes through the API gateway. The API gateway acts like a traffic controller. The gateway handles routing, path rewriting, load balancing, core management. Routing decide which service should handle each request, and path rewriting convert front-end paths into internal service paths. Load balancing distributes load across service instance, and core management allow browser requests from different ports. For example, these are the routes: API user, user service, API document, document service, API version, versioning. This design hides internal backend details from the backend. Even if I change a service port tomorrow, the frontend stay unaffected because only the gateway needs updating. The third one is WebSocket real-time text editing. Since this is a collaborative editing system, real-time updates are essential. For what for that I use subsockets. When multiple users are editing the same document, WebSockets keep a continuous open connection between frontend and backend. I use the STOMP protocol for publish subscribe messaging. Whenever one user types something, all connected users see it instantly. For example, if a user A types hello, the collaborative service receives this event. At the same moment, user B and user C see the updated text. This creates a real-time Google Docs-like editing experience. And the fourth one is server sent events live document update. For additional live document updates, I use server sent events. SSE is one way continuous stream from server to client. Whenever the document change, the server automatically push an update. This means the client does not have the constantly request updates. The server update the client in a real time. And the summary of this: REST APIs service talk to each other. API gateway frontend communicate with backend. WebSockets real-time multiple users collaboration. SSE continuous document update stream. And the second question is how document sharing works. Now I will explain how one user share a document with another user. Owner owner initiates sharing. User A is a owner, sends a share request. It includes target user ID and permission type, read or edit. This tells the system who should receive access and what level of access they should have. The second one is collaboration service stores the sharing records. This step is very important because it follows good microservice architecture principle. The collaboration service creates a new entry in its own database, document ID shared with user ID, permission. For example, document ID is 1, the user ID is 2, and the permission is added. Notice that case service does not share database. Each service maintains its own data integrity. The third one, shared user get access. As soon as sharing is saved, user B can see the document under share with me on the front end. If permission is equal to read, the user can only view. If permission is added, the user can fully edit in real time. Access validation. Security is also handled properly. Every time a user B open the document or tries to edit it, the collaboration service check if the user is authorized, access granted. If not, request rejected. This ensures no one gets access beyond their assigned permissions. Basically, the summary of this question is owner send the share request, collaboration service stores permission, target user see shared documents, and the last one is access is validated on every action. Thank you.